Have you ever stopped to think about how massive companies keep their shiny new cloud systems in sync with their old workhorse factory systems without everything just grinding to a halt? It's a huge challenge. Well, today we're diving into a really slick, event-driven architecture that does just that, syncing item data between Oracle's cloud and its classic e-business suite. And let me tell you, the principles here are a total game changer for anyone working in enterprise IT.
So here's how we're going to break it down. First, we'll get right into the core problem, the dilemma. Then we'll introduce the 4 key players that make up the solution. After that, we'll follow a single piece of data through its entire journey. We'll also cover what happens when things go wrong, because let's be honest, they always do. And finally, we'll look at why this design is just a fantastic example of modern, resilient architecture.
All right, so let's set the stage. This is a situation so many large companies are in right now. They are all in on the cloud for its speed and power, especially for managing product data. But, those critical, legacy systems running the actual factory floor? Yeah, those aren't going anywhere anytime soon. And that's where the integration headache really starts.
So you've got this split personality. On one side, you have Oracle Fusion PDH Cloud. Think of this as the master, the single source of truth, where every new product idea is born and defined. Then, on the other side, you've got Oracle e-business suite, the workhorse. This is the system that takes that product data and actually builds things. The challenge? Making sure every single item created in the master makes it to the workhorse perfectly, reliably, every single time.
The solution here isn't just one piece of magic software. Instead, it's a team of 4 distinct components all working together, each with a very specific job. So let's go ahead and meet the players who make this integration possible.
First on the list is Oracle Fusion PDH, and the absolute #1 rule of this whole architecture is simple. This is the master. It is the only place where items are ever created or changed. Just establishing that one rule wipes out so much of the chaos you see in systems that try to sync data back and forth.
Next, we have Oracle Integration Cloud, or OIC. But what's really important here is what OIC doesn't do. It's not a big, clunky data processing engine. A better way to think of it is as a lean traffic cop. It just directs the flow of information. It listens for events, makes calls to other systems, but it never gets bogged down in complex business logic or validation. That's key to keeping this whole thing simple and agile.
And now for the secret weapon of this entire design, the Oracle ATP database. Think of it like a bouncer for your data. It's a completely separate, decoupled layer that validates everything before it even thinks about getting close to the legacy system. This is where all the custom business rules live, and where every single error gets logged. This idea of decoupling the validation logic is the absolute game changer.
And finally, our destination, Oracle e-business suite. It's the downstream system, the workhorse. And because of this architecture, it gets exactly what it needs: clean, validated, and complete data. This way, it can just focus on running the business without having to second-guess the information it receives. Okay, so we've met the whole team. Now for the fun part. Let's actually follow the data. We're going to track a single new item through its entire 6-step journey, right from the moment of creation all the way to its final arrival in the legacy system. Here's the flight plan at a high level. It all kicks off with an event in Fusion. IOEC hears that event and picks it up. Then, OIC cleverly goes back to get the full data payload. It sends that data over to our bouncer, the ATD database, for a thorough check. Once it's approved, the data is loaded into EBS. And, crucially, there's a whole process for retry and recovery if anything fails. So let's dig into each step.
Right, don't worry about the whole diagram just yet. We're just focusing on that first little box on the top left. The whole process starts when a user creates or updates an item in Fusion. That one action automatically publishes something called a business event. And what's so important here is that this is a standard out-of-the-box feature, not some fragile custom code that kicks this whole thing off.
Okay, so that event goes out, and our traffic cop, OIC, which is always listening, immediately spots it. It grabs the message, but, and this is a really smart design choice, that initial message is super lightweight. It's basically just a headline saying, hey, item 123 was updated. The system never assumes that first little ping contains the whole story. So what happens next is absolutely crucial. Because that first event was just a headline, OIC's next move is to immediately call back to Fusion using a standard REST API to get the full story. Every attribute, every spec, every detail. This step ensures that we're always working with the most complete and authoritative version of the data, not just a little snippet. Now that OIC has the full, enriched data, it sends it over to our bouncer, the ATP database. And this is the critical quality gate.
A procedure inside ATP runs through a whole checklist. Does this item have all the mandatory fields for the legacy system? Does a value need to be remapped to an old format? It enforces all of these specific business rules before that data can get anywhere near EBS.
Once the data passes inspection and gets the green light from ATP, OIC makes one final call. It uses a standard, supported public API to load the item into EBS. You know, using a supported API is so important. It's like using the official front door instead of trying to sneak in through a back window. It guarantees the data goes in correctly, and it means the whole solution won't just break the next time the system gets an upgrade.
Okay, so that was the happy path, right? That's when everything works just perfectly. But we all know the real world is messy. Data can be incomplete, systems can have hiccups. A truly great architecture always plans for failure, and this one has a really smart safety net built right in.
So we have to ask the big question. What happens when the data is just wrong? What if it fails that validation check inside the ATP database? Does it just get lost forever in some log file? No way. Any failure is immediately written to a central global error table right there in the ATP database. It captures everything: the item ID, what went wrong, the status, a timestamp. The key here is that the error is persisted. It's not just a temporary message in a queue that can disappear. It's saved in a database, ready for action.
And having that error table allows for this brilliant hybrid retry strategy. You get the best of both worlds. For urgent issues, a support team can go in, fix the source data, and then manually re-trigger the process for that one failed item. But for less critical errors, a scheduled automated job can just periodically scan the table and retry any that are eligible. You get manual control when you need it and automated recovery for everything else.
So we've seen how all the pieces work. Let's just zoom out for a second and wrap up by focusing on why this design is so effective. What are the core principles that make it so robust, and what are the real-world payoffs? The success of this whole thing really boils down to three simple, yet incredibly powerful principles. Number one, Fusion PDH is the one and only master, no exceptions. Number two, OIC is just a lean orchestrator, a traffic cop, not a big data processor. And number three, all that custom validation and error handling is offloaded to a separate, decoupled ATP layer.
And following those principles delivers massive benefits. When you have one master, you totally eliminate those painful data conflicts. By keeping OIC lean and putting validation in ATP, the whole system becomes way easier to support and troubleshoot. You get these really clean boundaries between your systems, and maybe most importantly, you guarantee that the data landing in that critical legacy system is rock solid.
This really brings us to a final, bigger thought. We looked at this today through the lens of Oracle products, but the principles themselves are universal. Have a single source of truth, use a lean orchestrator, and decouple your custom logic. So I'll just leave you with this question to think about. Is this smart, decoupled, event-driven approach the future of how all our complex enterprise systems should be talking to each other?